know what is your matrix. Okay, what is a matrix? It is a rectangular arrangement of rows and columns. Then you should know what are the types of matrices we have. In that specifically, you should know what is your identity matrix. Then what is a triangular matrix, upper triangular, lower triangular. And then you should know what is a diagonal matrix, what is a scalar matrix. And then we went into characteristic equation. Finding out your characteristic equation is very, very important, because with your characteristic equation only we'll be solving all the problems. Okay, that is when you're finding out your Cayley-Hamilton theorem. So verify whether it is satisfying Cayley-Hamilton theorem means you need to know your characteristic equation formula. Your general formula, you know, your general formula I told you, that is modulus of A minus lambda I equal to 0. Okay, this is your general formula of your characteristic equation. If you don't remember your formula for the 2 cross 2 and your 3 cross 3, you can try it out with this. Otherwise, if you remember, you should remember that is your 2 cross 2 matrix means your formula will be lambda square minus S1 lambda plus S2 equal to 0. Okay, this will be the general formula for your 2 cross 2. Not general formula, it will be your characteristic equation. Okay, general formula will be this. Your characteristic equation for a 2 cross 2 matrix, it will be lambda square minus S1 lambda plus S2 equal to 0. Your S1 will be the sum of the main diagonal elements. S2 is your determinant of it. Okay, for a 3 cross 3 matrix, it will be lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Okay, and here your S1 is your sum of the main diagonal elements, S2 is the sum of the minus of the main diagonal elements, and S3 is your determinant of A. Okay, after finding out your characteristic equation, if they are asked to verify your Cayley-Hamilton theorem, what does it imply? Every square matrix satisfies its own characteristic equation. You have to write that definition, and then you'll have to, wherever there is lambda, you will take it as A. Okay, the given matrix will become there A. So instead of lambda, you will take it as A and equate it, and you have to make it equal to 0. It will become 0 if it is a square matrix. Okay, it will satisfy its own characteristic equation. So that is your Cayley-Hamilton theorem. Then we went into finding out your eigenvalues and eigenvectors. How do you find out your eigenvalues and eigenvectors also? You understood. So how do you do it? You will substitute the values of lambda. Don't unnecessarily unmute yourself. If you want to talk something, the subject, you can. Yeah. So after that, you will find out your eigenvalues. For the corresponding eigenvalues, you will find out your eigenvectors. Okay, till this we have finished. Now we will go on to the properties. Okay, so 2 marks questions. So from this properties, we will be using 2 mark questions. Okay, from here you will be getting 2 marks questions, and in your MCQ also they can ask you. So write your today's date, and write your heading as properties. Properties of eigenvalues and eigenvectors. So in that, your property 1. Okay. Your first property is, in your first property itself, we have got 2 subdivision. That is the sum of the eigenvalues. The sum of the eigenvalues of a matrix. Sum of the eigenvalues of a matrix is the sum of the elements. The sum of the elements. Write it down. The sum of the eigenvalues of a matrix is the sum of the elements of the principal or main diagonal. The main diagonal elements is the sum of the elements of the principal diagonal. Okay, so whatever sum of the eigenvalues, like example, you can take your last problem and see what is your eigenvalues which you've got. That value is you take the sum. Okay, you are taking the sum that will be equal to the sum of the elements in the diagonal. Okay, the diagonal value which you have got in that matrix, that will be equal. Okay, so that will be your first property. And your second property, in the property 1 itself, second subdivision, it will be product of the eigenvalues. Product of the eigenvalues. Product of the eigenvalues is equal to the determinant of the matrix. Is equal to the determinant of the matrix. So this is your property 1. Okay, we verify this property. Okay, so with the problems which we have already done, we will see whether this is getting satisfied. Okay, so we will take the problems. We have done it already. So I will take one problem. Okay, we have done a problem like we have got the values for this lambda. Tell me some values. Lambda. We'll take this value. Yeah. The first problem which we took, that is 1, 0, minus 1, 1, 2, 1, 2, 2, 3. Okay. We had found out eigenvalues and eigenvectors for this problem. Okay. Have you written the property? Write the property quickly. The property is sum of the eigenvalues of a matrix is the sum of the elements of the main diagonal. Okay. And the next property, in the same property, you can write product of the eigenvalues is equal to the determinant of the matrix. Okay. So these are the two properties these are the two subdivisions in the first property. Okay. Very, very important property. In this, many questions can be asked. Okay. So when you found out your eigenvalue and eigenvector for this one, what was your lambda? Tell me your lambda values for this problem. For this given matrix, what was your lambda? You found out this, no? Tell me your lambda values for this problem. See your notebook and tell me for the given matrix, what was your lambda values? Found out your lambda values. Okay, what is the value of your lambda? Tell me. So you had got 1, 2, 3, isn't it? Your lambda values, you got 1, 2, and 3. So according to the formula, according to the property, the sum of the eigenvalues, okay? The sum of the eigenvalues. So this is your eigenvalues. The sum of this eigenvalues will be what? Sum of the eigenvalue. You're going to add everything. So you're going to add these values. When you add these values, what you get? When you add these values, it will be 1 plus 2 plus 3, which will be 6. Okay. The sum of the eigenvalues is equal to the sum of the values in the diagonal, sum of the elements in the main diagonal. Okay, that is what we have written. Sum of the eigenvalues is equal to the sum of the elements in the main diagonal. So this will be your main diagonal. Okay, so this is equal to the sum of the main diagonal elements. So here your main diagonal values are 1, 2, and 3. So here again you find out the sum of the elements in the main diagonal. The main diagonal. So that will be what? Main diagonal. So that is also equal to. So your property 1 is satisfying. So your property 1, what is it is? Your sum of the eigenvalues. Whatever eigenvalues you are getting for the matrix, that will be equal to the sum of the elements in the diagonal elements. So that's how you will see whether whatever eigenvalue you have got is correct or wrong. Okay. So that is one of the way of checking it. And next property is product of the eigenvalues is equal to the determinant of the matrix. Okay, so product. Here you've got your lambda values, your eigenvalues that are to be 1, 2, 3. So they have given product of the eigenvalues. So for the given problem, if you find the product of your eigenvalues will be, you will multiply it. So there also you get 6. Okay. In the same problem, you find out your determinant of A. See what was your determinant of A. What was your determinant of A? That will also be equal to 6. Okay. For this problem, your determinant of A is equal to 6. So in this property, according to this property, when you have got your eigenvalues, the sum of the eigenvalues will be equal to the sum of the main diagonal elements, and product of the eigenvalues will be equal to the determinant of A. So this is how you will check whether you've got the lambda values correct or wrong. Okay, this is one shortcut. So write it down. Okay, we will do problems related with this property. This I've done because you have already done this problem. You have already found out this lambda value and you have found out this determinant of A and all. So we just see whether you're getting the same answer. For all the problem that you have done for finding out your eigenvalue and eigenvector, all the problem you can check. Okay, see whether your sum of the eigenvalues is equal to the sum of the main diagonal elements. And similarly, product of your eigenvalues is equal to determinant of A. It will satisfy. Okay. Have you finished writing the property? You have finished writing the property. We will go on to problems. Have you written it down? Yes or no? Finished writing? Tell me yes or no. Why are you all very silent? Tell. Have you all finished writing?
Yes.
Okay, I take you finished writing. Okay, so I will rub it. Okay. So according to your property 1, what does it say is the sum of your eigenvalues. So whatever eigenvalues you're getting, the sum of that eigenvalues will be equal to the sum of the main diagonal elements. Okay. And similarly, product of the eigenvalues will be equal to determinant of it. Okay. So that is your property 1. With this property, we will do some problems. Okay. Find the sum. So in the question they've asked, find the sum and product. Find the sum and product and product of eigenvalues of the eigenvalues of the matrix that depends on the matrix there. A 3 cross 3 matrix is being given. Okay, minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Okay, so this is the given matrix. They've asked you to find out your sum and your product. Okay, so in this, what you will do is you will directly use the formula. Your formula is to find out your sum of the eigenvalue. It is nothing but it is the sum of the elements in the diagonal. Okay, so first important point is in the question if they are not mentioning any matrix symbol. Okay, now for this they have not given you any matrix that is A, B or C. Okay, you have to denote it. Okay, whatever matrix is there, you will denote it and then only start the problem. So since they have not denoted with any symbol like A, B, C or some capital letter words, so you will take let A is equal to, you will write in the solution, let your given matrix A is equal to the given matrix. Okay, in the question if they have not mentioned any matrix symbol, you will take that as capital A or capital B, whatever it is. You can take it in one matrix format and you then represent the given matrix. Okay. So the given matrix I represented by A, and then you find out your sum. So sum of the eigenvalues, you know what is your sum of the eigenvalues. So for this, you need not find out your characteristic equation. Sit and find out your characteristic equation, then find out your eigenvalues, sum of the eigenvalues. Instead, what you can do, your value will be sum of the elements of the main diagonal elements. So it will be -1, -1, -1, which will become -3. So your sum of the eigenvalues will be -3. Similarly, product. When you find out the product of the eigenvalue, you need not find out the characteristic equation and find out your eigenvalue. You can directly substitute the formula. Product of the eigenvalue is equal to determinant of A. So find out your determinant of A. So product of the eigenvalues is equal to determinant of A. I told you to represent this because here you then only you can represent. Otherwise, you should write the whole values. Okay, you have to put the whole values -1, 1, 1, -1, 1, 1, 1, -1. Now multiply and find out your determinant. So that will become the product of the eigenvalue. So when you multiply, you have -1 into 1, -1, -1 into -1, -1, plus 1 into 1 plus 1. So what do you think? Find out and tell me. Minus into minus, here it becomes 0. Here it will become 2. Here also 2. So your product of the eigenvalues is equal to 4. Okay. So this is how you're going to find out your sum of the eigenvalues of a matrix. I will give you one problem as homework. You will do it as homework. Okay. For this matrix, you try finding out your sum and product. -2, 2, -3, 2, 1, -6, -1, -2, 0. This will be homework problem. Okay. -2, 2, -3, 2, 1, -6, -1, -2, and 0. Okay, that you will do it as homework. Next. So this problem you do it as homework. Okay. Now to write down this. Two of the have you written this problem? Right. Two of the eigenvalues. Two of the eigenvalues of the matrix 6 -2, 2, -2, 3, -1, 2, -1, 3. Okay. So two of the eigenvalues of this matrix are 2 and 8. So they have given 2 and 8. They have already given the eigenvalue. Eigenvector they have given. Okay, are 2 and 8. So two eigenvalues are given. Find the third. You have to find the third eigenvalue. Find the third eigenvalue. Tell me how you can do this. How you can do this? See, you've been given the eigenvalue. Two eigenvalues they've given, and this is a 3 cross 3 vector, 3 cross 3 matrix. Since it is a 3 cross 3 matrix, you should have 3 eigenvalues. So you should find the third eigenvalue. What and all you got, with that what you can find? Tell me. Let me see how anyone can find it. With the property 1 only, you're going to find out your third eigenvalue. What if you use, you will find out the third value. Tell me. Think and tell what you will do. Have any idea? So first you'll have to represent your lambda 1, lambda 2 and lambda 3 as your eigenvalues. Okay, so you will take your lambda 1, lambda 2, lambda 3. And they have given your lambda 1 to be 2, lambda 2 to be 8. Now you have to find out your lambda 3. Okay, so that is your question. So how do you find out? So write it down. Write it down. First, since the given matrix is not represented, you write let A is equal to. A is equal to, write the given matrix. Okay, always represent your matrix and then go on to the problem. Minus 2, 3, minus 1, 2, minus 1 and 3. Okay, so first you will represent your matrix with the capital letter. So I'm representing it with the capital A. Okay, after that you write what and all. Let your lambda 1, lambda 2, lambda 3 be the eigenvectors, eigenvalues, be the eigenvalues of the given matrix A, okay, of the matrix A. Now they have given, what and all they have given in the question. They have given your lambda 1 is equal to 2. That is your two eigenvalues they have given. Okay. So lambda 1 is equal to 2 and lambda 2 is equal to 8. You don't know what is your lambda 3. Don't know what is your lambda 3. Now you have to find out your lambda 3. How do you find out? Okay. So according to the property, sum of the eigenvalues means lambda 1 plus lambda 2 plus lambda 3 is equal to sum of the main diagonal elements. Sum of the main diagonal elements. That is 6 plus 3 plus 3. Sum of the main diagonal elements. Okay. So you know the value of lambda 1, that is 2 plus 8 plus lambda 3 equal to added. So it will be 9 and 12. Okay. So you need to find out your lambda 3. So when you add this, this will become 11 plus lambda 3 equal to 12. 11, 10. Okay, 10 plus lambda 3 equal to 12. So your lambda 3 is equal to 2. Found out the third eigen. Okay. This is using your sum. Same way you can use it with your product. How can you do it with your product? How do you do it with your product? Product of the eigenvalues is equal to the determinant of A. So that is what lambda 1, lambda 2, lambda 3 equal to determinant of A. Okay, this is also one of the property. So your product of your eigenvalues is equal to determinant of A. So you know what is your lambda 1, lambda 2. So a 2 into 8 will become 16 lambda 3 is equal to find out your determinant. Okay, you're going to find out your determinant. So that will be 6 into, find out, it will be 9 minus 1. Minus into minus plus 2. Plus 2 into, you have minus 6 taking plus 2 into minus 6 plus 2 plus 2 into graph 2 minus 6. So when it will be, this is 8, it will be minus 4 and this will also be minus 4. So when you multiply, you will have 8 6 48 and here it will be minus 8 minus 8. Okay, so 48 minus 8 minus 8, it is 32. Yeah. So 16 lambda 3 is equal to 32. You're not able to see that. So it is equal to 32. So your 16 lambda 3 is equal to 32. So your lambda 3 is equal to 32 by 16, which is equal to 2. So your lambda 3 is equal to your third eigenvalue. Okay. You can do this format or this format. It is whichever you are feeling it comfortable, you can do it. Okay. This is easier because there you're going to do multiplication. You're finding out determinant of A. Okay. If it is MCQ pattern question, try to do it with this property. Okay. The first subdivision in the property 1 so that it will be easier for you. It is just the sum of the eigenvalues equal to the sum of the main diagonal elements. Whereas this will be product of the eigenvalues equal to determinant of A. But if in the question they have asked you do it using your product property, then you should do that one. Okay. Both the method you will get the same one. So your eigenvalues here will be what? 2, 8 and 2. So 2 times you've got 2 and 1. Write it down. If you've got doubts, ask me. So this is your property 1. The same problem I have done both the methods. Okay. That is product. Next we've gone to the second property. Any doubts with your first property? This property many places we will be using. You can check it actually. When you're finding out your eigenvalue and eigenvector, now there you can check it whether you've got your eigenvalues correct or not. This is one verification. So when you solve that equation and get the characteristic equation, now then after getting the characteristic equation, you will solve it and get the roots. When you get the roots, you will not know whether it is correct or wrong. So with this method, you can solve it. Here, if it is equal to the sum of the main diagonal elements, whatever you've got your eigenvalues. Okay, and when you can do the product and see your determinant, however you will find out your determinant. Okay, you'll find out your S3, which is your determinant of A. If it is equal to the product of the eigenvalues, that is also okay. So through verification, you can do it when you're doing your eigenvalue and eigen. So next is second property. A square matrix A, a square matrix A, and its transpose, and its transpose, and its transpose have the same eigenvalues. Have the same eigenvalues. Okay. So given matrix A, they have given in the MCQ if they are given, they will ask you the eigenvalues of the matrix are such and such. Okay, for example, 3, 4, 5. Okay, and they're asking you in the MCQ itself, write the eigenvalue of its transpose. That is nothing but the same one. Okay, so you need not sit and find out the transpose and then find out your eigenvalue. You will get the same eigenvalue. Okay, even if you're finding the A transpose and again solving it and finding out the eigenvalues, it is the same. So from this property itself, if they're asking in the question, find the transpose of the given matrix, and they've given the eigenvalues of the given matrix means, what does it imply? The matrix A and its transpose will have the same eigenvalues from this property. So we will do one problem related to this. If 2, 2, 3 are the eigenvalues are the eigenvalues of A is equal to 3, 10, 5, minus 2, minus 3, minus 4, 3, 5, and 7. Find the eigenvalues. Find the eigenvalues of A transpose. Find the eigenvalues of A transpose. So if you don't remember that this property, one property like this exists, if you don't remember that, what you will be doing? You will again start to find out your characteristic equation, then solve it, get the value. Whereas if you remember this property, what does it imply? Whatever matrix A, that same matrix for the transpose also, that will have the same eigenvalue. So because of this property, you can write it in the solution. What will be A transpose eigenvalue? Your A transpose eigenvalues will be also 2, 2, by this property. Okay? So in your 1 mark question only, these and all will be asked. So you have to remember that the matrix and given matrix and the transpose will have the same eigenvalue. You need not find out your characteristic equation and solve that equation, get it. Next will be property 3. If anyone wants to try it, you can try it, okay? You can find out that A transpose and find out your characteristic equation. And then solve it, get your eigenvalues. When you're finding out your eigenvalues there, see whether you're getting the same eigenvalue. Next, we will go on to property 3. Property 3 is the characteristic roots. The characteristic roots means what? Characteristic roots is also eigenvalues. Okay? The characteristics roots of a triangular matrix the characteristic roots of a triangular matrix are just the diagonal elements of the matrix. So the characteristic roots of a triangular matrix are just the diagonal elements of the matrix. This characteristic roots can be also written as eigenvalues. Nothing but eigenvalues, okay? Getting confused. So this is your this. For this, an example. So if they have given, find the eigenvalues. Find the eigenvalues of A is equal to 2, 1, 0, 0, 2, 1, 0, 0, 2. Without using the characteristic equation idea. So in the question itself, they've given. You must not use your characteristic equation. You must not find out your characteristic equation and then get your eigenvalues. So here, what does it imply? Means if it is a triangular matrix. Now here, if you see what triangular matrix is this? See, this is a triangular matrix. What triangular matrix is this? Since you've got 0 down and values on top, it is an upper triangular matrix. Okay. Since it is an upper triangular matrix, the values which are there in the main diagonal elements, that will become your eigenvalue. Only for upper triangular matrix or lower triangular matrix. Okay. So since you can write in your solution, it is an upper triangular matrix. It is an upper triangular matrix. Since it is an upper triangular matrix, what you can write? Your eigenvalues will be the elements in the main diagonal elements. So your lambda values will be 2, 2, and 2. That's all. Okay, so if it is a triangular matrix, you can easily find out your eigenvalues. How you can find out? If it is an upper triangular matrix or lower triangular matrix, you will write the values in the diagonal elements. That will become the eigenvalue. So I will write another question that you tell me. For this, what is your eigenvalue? I will write it here. The values are 2, 0, 0, 1, 3, 0, and 0, 4, 4. Tell me, what matrix is this? Tell me. I've given one example here. Another example I've given there. It is a lower triangular matrix. Okay, it is a lower triangular matrix. We will represent it as A. It is a lower triangular matrix. What will be your eigenvalue by this property? Tell what will be the values? Yeah, you're all listening or what? You see? So your eigenvalues will be what from the given matrix? The eigenvalues will be 2, 3, and 4 because it is a lower triangular matrix. Since it's a triangular matrix, if it is a triangular matrix, from that, how you can find the eigenvalues? That is nothing but the elements in the diagonal. Okay, so here if you see the elements are 2, 3, and 4. So your lambda values will be 2, 3. Okay, so with this, we'll finish it for today. I'll take the attendance. Tell me 1,